Hello, mathematicians. How are you today? My name is Jessica Johnson, and today I want to teach you about fractions and rational numbers. We need to take these 10 grams and to make them into fractions. How do we do this? You have to take the hexagon, triangle, trapezoid, and rhombus and ask yourself, how many of these will fit inside of a base unit? And your base units will also be a hexagon or a trapezoid or a triangle or a rhombus. Let me show you what I mean. Take the hexagon as a base unit. Ask yourself how many trapezoids will fit into one hexagon. 2 trapezoids will fit into one hexagon. 6 triangles will fit into the one base unit of a hexagon. So you get 6 triangles over one hexagon. And 3 rhombi, I also like saying the word rhombi, will go into one hexagon. If you have the trapezoid as a base unit, 1.5 hexagon will go into one trapezoid. 3 triangles will go into one trapezoid. And 3 seconds of a rhombi will fit into one trapezoid. 1/6 of a hexagon will fit into one triangle. I really like how these work out and show you how this works. 1/3 of a trapezoid will fit into one triangle. And 1/2 rhombi will fit into one triangle. And with the rhombus as your base unit, 1/3 hexagon will fit into one rhombus. And 2/3 of a trapezoid will fit into one rhombus. And 2 triangles will fit into one rhombus. Okay, I love this problem. We have a gentleman that has bought some rope, but he can't remember how long his original rope was in length when he purchased it. He asked us for help. This is what we know. He used 1/3 of the rope to make a bow painter for his canoe. He used 1/4 of the rope to tie up some carpet. And he has 36 feet of the rope left over. Start with what you know. We need to divide our rope up with the information that we know. We know that he used 1/3 of the rope for the bow painter. He used 1/4 of the rope to tie up some carpet. And there's 36 feet of the rope left over. Divide your rope into equal sections. The part that is only 36 feet is what we're going to divide into equal sections. Now you need to count your sections. We have 4 equal sections. And 36 divided by 4 equals 9. So that section represents 9. Each of these sections will represent 9 feet. Divide the rest of the rope into equal parts. And these are equal parts of a foot. And you have 8 equal parts equaling 9 feet. And 8 times 9 equals 72. The gentleman's rope was 72 feet long when he purchased it. I'm so glad we were able to help him figure out how long his rope was when he purchased it. We need to represent the listed fractions with fraction strips and number lines. And these are so much fun. And also, I'd like to tell you that here, these are examples of rational numbers. 1/3, 1/2, all of these are rational numbers because A is over B, and B cannot equal 0 because you cannot divide by 0. To represent fractions with fraction strips, you take your fraction strips and place them side by side. For this example, you're going to take a fraction strip representing 1/3 and a fraction strip representing 1/2 and place them side by side. Then you ask yourself, how many fractions can fit into both of these fraction strips? Well, 1/6 can 5 times. Now look at your answer over here, 5/6. If you add these ones, 5 times 1 equals 5, and our denominator is 6. I love how that works out with fraction strips. I want to show you 2 ways that you can represent fractions with different denominators on a number line. Here's the first way. And you can decide on your own which way you like the best. We need to build 2 number lines. The first number line is going to represent 1/3. Put a tick for the 1/3 mark. We will use the denominator from 1/2 to know how to equally divide the number line in the number line on the 1/3. I want to go ahead and add 2/3 and 3 threes on the number line to help you understand that we're dividing in parts of a whole. Build a separate number line to represent 1/2. Use the denominator in 1/3 to know how to equally section off the 1/2 number line. Go back to the 1/3 number line for a moment. Count your ticks. From here to here, we have 2 ticks. Go to the 1/3 number line and count your ticks. From here to here, we have 1, 2, 3 ticks. When you add the 2 and the 3 together, that is going to be your numerator. And the ticks all the way across the number line, if you notice, each number line has 6 ticks. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That is your denominator. Pretty cool how that works out, huh? And this represents 5/6 when adding 2 and 3 together. To represent 1/2 plus 3/4, you're going to do the same procedures, and our answer will be 5/4 or 1 1/4. A second way I want to show you how to use a number line to add fractions with different denominators is by starting with the least common multiple. For 1/2 plus 2/3, the least common multiple is 4. Build your number line with fractions with the same denominator, 1/4, 2/4, 3/4, and 4/4. Because we have the same denominator, we only need to add the numerators. Add 2/4 plus 3/4 equaling 5/4. Since our line will go past the whole mark, 4, 4, we know that we have a mixed number fraction. When adding fractions on a number line, your arrows need to come out of the other arrow, just like this. Doop, doop. Be sure to start at 0. Using fraction strips to represent 3/4 minus 1/3. The same rules apply. The only thing is when you're subtracting fractions using fraction strips, you need to stack your fraction strips. So represent 3/4 and 1/3. Now, what fraction will fit in our empty space right here? 5 1/12 will. So the only difference is when you're adding and subtracting fractions with fraction strips, when you're adding, you stack them side by side. When you're subtracting, you stack them on top of each other. And our answer is 5/12. To subtract fractions with a number line, some of the rules are the same, but some are different. Let me explain. For example, 3/4 minus 1/3. We need a least common multiple between the denominators of 4 and 3, and it is 12. The 12 tells how to equally section off the number line. To put the fractions on the number line, we know how many ticks, we know to put fractions on the number line, look at the numerator to know how many ticks to count off. For 9 12s, count off 9 ticks. For 4 12s, count off 4 ticks. This is the part that I like. Look at the ticks under the small jump. There's 1, 2, 3, 4, 5. That's your numerator. And the ticks all the way across the number line that is sectioned off equally is 12, which is your denominator, giving us the answer of 5 12s. Pretty neat how that works out, huh? And one more point, I'm sorry. When subtracting fractions on the number line, your arrows must meet. Three-fourths minus 3/6 using fraction strips will be 3/12. But we know that that can be simplified to 1/4. Let me show you what 3/4 minus 3/6 looks like on a number line. We know our number line needs to be equally divided by our denominator 12. We'll count our ticks off, and we'll get the answer 3/12. We need to represent these fractions using fraction circles and number lines. The integer in front of the fraction, that's what we're multiplying our fraction by. This tells you how many circles that we need to use, how many fraction circles we need to use. The fraction tells you how to divide the fraction circle up. 3 times 1/5 means that we need 3 1/5 circles. Count the colored triangles, 1, 2, and 3, and you get 3/5. To represent 3 times 1/5 on a number line, the denominator tells you how to equally separate each whole of the number line. The integer tells you how many times we need to multiply. The numerator tells you how many ticks to multiply by. For example, we need to multiply 1 tick 3 times. This is the same as 3 times 1 equals 3. The 3 is the numerator, and the equal ticks in each whole is the denominator. Since we have 5 ticks, 1, 2, 3, 4, 5, our denominator is 5. This gives you the fraction of 3/5. 3 times 2/4 would have 3 2/4 fraction circles, and this equals 6/4 or 1/2. 3 times 2/4 on the number line will look like this. And our answer is the same, of 2/3 or 1.5. 5 times 5 8 will, with fraction circles, will look like this. Not only does our fraction circles represent 25/8, but it also represents 3 1/8. 5 times 5/8 on a number line will look like this. And our answer is 25/8 or 3 1/8. Let's look at -5 times 5/8. Don't let the negative sign throw you off. You still need to represent -5 times 5/8 the same way you represented 5 times 5/8. But how do you get the negative part? Well, that's easy. I ate 3 1/8 pecan pies. They were delicious. That's how you get the negative, because they're taken away. To represent -5 times 5/8 on the number line, the same rules apply. The only difference is you're on the other side of the line where you're working with negative numbers. But our answer would still be the same, -3 1/8. Let's look at these 7 10 grams. They're arranged in areas A, B, C, D, E, F, and G. Here's our answers. Area A and area B will equal 1/4 of the square unit. Area C equals 1/16 of the square unit. 1/8 is area D, and area E is 1/16 square units, and area F and area G is going to be 1/8 square units. Let me show you. Just imagine a blank square for a moment. The key is to look at the square as a whole. Look at area A. Divide the square to look like area A. You get a square broken into quarters. Therefore, area A is 1/4. Do the same that you did for area A for area B. Imagine a blank square. Look at area B. Area A and B are the same size. Therefore, area B is 1/4 of the whole square. Area C. This one seems to go all over the place, but if you hang with me, I promise it will come together in the end. Imagine area D is divided into triangles. Now, divide area G into triangles. Now then, look at only areas C, D, and G. This is one unit now. And place this unit here, here, and here. This is what it will look like. How many triangles do you have in all? There are 16. Area C is equal to 1/16. I told you it would come together in the end. Area D. Now look at area D. Look at area C as 1/16. We can easily figure out area D. Break it down. Look at only area D for just a moment. Now divide area D into 2 triangles. What do you see? You see 2 area Cs, right? Therefore, area D is 1/18. Let me show you. 1/16 plus 1/16 equals 2/16. When you simplify, you get 1/8. Area E. Again, break the problem down. Look at only area E. Turn area E to look like area C. They are equal areas. Therefore, area E equals 1/16. Look at area F. Don't let the parallelogram scare you. Think of it as a square that got pushed over just a tad bit. You have 2 ways to solve this problem. A, look at area D, because area F is a square, and area D equals 1/8. So F would equal 1/8, but I don't like that way. Let's look at option B. Divide the parallelogram into triangles. These triangles represent 1/16. And we've already learned when you have 2 1/16 and you simplify it, you get 1/8. Area F equals 1/8. Look at area G by itself. Draw a line to divide it into triangles. And guess what? 2 1/16 simplified is 1/8. Area G equals 1/8. Now, let's make some delicious brownies. Here's our dilemma. Our recipe calls for 16 brownies, but we only need to make 12. How can we fix this problem? Let me show you how. Start with the serving size that you need, which is 12, and divide by the giving serving size, which is 16. So we have 12 divided by 16, which can be simplified by dividing by 4. So 12/16 equals 3/4. We will need to multiply each of these ingredients by 3/4. That is how we get our answer of, we need 1/4 cup of butter, 2 1/4 cups of unsweetened chocolate, 9/16 cup of sugar, 1 1/8 cup teaspoons of vanilla, 1 1/2 eggs, and 1/2 cup of flour. I hope you enjoyed my lesson on fractions, and I hope you have a good day. Thank you.